Okay, let's have a look. While driving down the road, a firefly strikes the windshield of a bus and makes a quite obvious mess in front of the face of the driver. This is a clear case of Newton's third law of motion. The action-reaction one, the firefly hits the bus and the bus hits the firefly. Which of the two forces is greater? The force on the firefly or the force on the bus? And just like Alex said, almost identical to the Moon Earth situation yesterday. Which one is greater? C. They are the same. Very nice to see everyone got that right.
I got this one wrong.
For years, space travel was believed to be impossible because there was nothing which rockets could push off of in space in order to provide the propulsion necessary to accelerate. This inability of a rocket to provide propulsion in space is because space is void of air, so the rockets have nothing to push off. Gravity is absent in space. Space is void of air, and so there is no air resistance in space, or nonsense. Rockets do accelerate in space and have been able to do so for a long time. Some people still believe you can accelerate a rocket in space, and it's only the acceleration in the Earth's atmosphere that takes place. And when they blast off from the moon, it's because they're pushing off of the moon. But those people are wrong. It is D. It is a common misconception that rockets are unable to accelerate in space. The fact is that rockets do accelerate. Make this a bit bigger for you. Rockets are able to accelerate due to the fact that they burn fuel and thrust exhaust gases in a direction opposite to the motion with which they wish to accelerate. It's a conservation of momentum thing. The gas fumes, the gas molecules go firing out at high speed, which causes the momentum of the rocket to change in the opposite direction. It is not pushing against the ground. Not true. So that correct answer there is D.
I wrote C on this. 3.
Many people are familiar with the fact that a rifle recoils when fired. This recoil is a result of action-reaction force pairs. A gunpowder explosion creates hot gases which expand outward, allowing the rifle to push forward on the bullet. Consistent with Newton's third law of motion, the bullet pushes backwards on the rifle. The acceleration of the recoiling rifle is?
Gases.
Correct answer is smaller than the acceleration of the bullet. Why is it smaller?
It's not the acceleration.
Mass of gun is bigger. The forces are the same, but are the accelerations the same? No. Why? Because of the mass of the gun is considerably larger. The force on the rifle equals the force on the bullet. Let me just make this bigger for you. The force on the rifle equals the force of the bullet, yet acceleration depends upon both force and mass. The bullet has a greater acceleration due to the fact that it has a smaller mass. Remember, acceleration and mass are inversely proportional. So how'd we do in that one? Not so good, eh?
We all wrote C because we were thinking that we didn't all right.
Well, many of you did. 5 of you wrote C. What's the same? The forces. Kent Swim, who's taking physics for the 3rd year in a row, and not because he likes it,
I got this one right.
has rowed his boat within 3 feet of the dock. Kent decides to jump onto the dock and turn around and dock his boat. Explain to Kent why this docking strategy is not a good strategy.
How does C not work? Because C is the same.
I know, let's read. It's a good idea provided he can jump 3 feet. He will make it to the dock, but the boat is likely to go backwards several feet and he won't be able to reach it. He will make it to the dock, but the boat is likely to go backwards 3 feet and might not be able to reach it. The boat will stay in the same spot, so he'll have to reach 3 feet back. The best answer is B, because he's quite likely going to be, he would be more massive than the boat, right?
Yes.
Possibly. And not only that, but how much friction is there slowing the boat down? Well, that's true, right? Yeah. The better answer is probably B. C would probably be okay, except I spelled likely wrong here. So, yeah. No. How'd we do there? Yeah.
Me and Riley got it right.
I would say
You
B.
got it right.
The boat will not stay in the same spot, though, because of conservation of momentum.
You're not right about everything, Alex.
Some clown is on the ice rink with a large medicine ball. Why do they call them medicine balls anyways, do you know? Yeah, like leftover aspirin or something?
You're pretty dense.
I was thinking that, but yeah. Didn't think I could say it. If the clown throws the ball forward, then he is set into backwards motion with the same momentum as the ball's forward momentum. What would happen to the clown if he goes through the motion of throwing the ball without actually letting go of it? This is a tough question. What's the correct answer? A. No, one person said A. Without actually letting go of the ball, the clown will not be displaced from his original position. He will move forward in his intended direction. No, the ball will move backward, causing him to go back as well. No, no, no. Let's read what the fine print says, because it can probably explain it better than me. Without letting go of the ball, the clown will not be displaced from his original position. He may slide backwards a little and then forward a little as he goes through the motion of throwing the ball, but when he's done the motion, he will be at rest in his original position because there is no momentum forward or backward, right? So he will actually stay in one place. Praise the clown. Last one, Chubby, Tubby, and Flubby. Are astronauts with the same mass and strength, they push with equal force each time. Chubby and Tubby decided to play catch with Flubby. Yes, I agree, Riley. A little bit of bullying going on. Intending to throw, it's a her, back and forth. How many throws will the game last? Will be 2 throws and 2 catches, 2 throws and 1 catch, 1 throw and 1 catch, or will they keep playing until Mom tells them to come on in for supper? And the correct answer is B.
Why is it?
2 throws and 1 catch.
So I wanted to change it at the end. Because like you can catch and throw again, but once you throw again, it's not going to catch up to the second person. You'd already accelerated anyway. So it's 2 throws. Otherwise, it's 1 throw.
Well, they're floating in space.
They're in
Well,
space.
they're astronauts. Why would astronauts be on the
Why
ground?
aren't they on the moon? Why do they play catch in the middle of space?
They're astronauts.
They're like can't swim. They took physics 3 times. When the red one goes like this, right? When blue pushes on the red one, what happens to blue?
Blue goes backwards, but black.
Blue goes backwards, right? Black can catch, but once red gets here, it's going to do that on me, right? Once red gets there, right, and then blue pushes again, even if black can actually push red back away, is red ever going to catch up to blue? Never, right? In fact, they're all screwed, aren't they? Yeah.
They're gonna die.
Yeah.
Yeah, that's a
Terrible last question.
Yeah? Kind of sad? Life's not all happy, you know.
Their life's ended because of bullying.
This is just a fictional story.
It's not fictional.
No astronauts were actually hurt in the making of this question.
It's based on true story.
No.